Okay, so we're a little bit at a loss of where to go from here. Well, we observe here that x3 is equal to 14, x4 is equal to 5, x1 is equal to 2. If we go back to the problem, we didn't know how to find our initial basic feasible solution to this problem with 5 variables. Okay, well now we know that our initial basic feasible solution, let's write down what the b is at this point. So the basic variables are x1, x3, and x4. And the non-basic variables are x2 and x5. We can forget all about x6. It was an artificial variable. We didn't know sure. So now we're on the shape. We have values for, we have 2. Let's go back again. We have 3 equations. So we didn't know which 2 variables. We have a total of 5 variables and 3 equations. We didn't know which 2 variables to set to 0. So when you solve for the other 3, you get a positive solution, which or positive or at least non-negative solution. And that was the problem. We have arrived at that point. We now know that we have x1, x3, and x4 is an x2 and x5, and those values for x3 and x4 and x1. That is a basic feasible solution. So this is an initial basic feasible solution. Okay, so we have arrived here at the end of the phase 1 with these equations with x3, x4, and x1 and z. And we've gotten rid of the artificial variables. So now we have found an initial basic feasible solution with x3, x4, x1. And we are now ready to continue from there, but with the original objective. So let's copy a few things from that slide onto here. So we've copied the equations from the previous, the x3, x4, x1, and now we're going to redefine our z, which is the original x1 plus 2x2. And therefore that becomes, and we now substitute, so that's going to be 2 plus 3x2 plus x5 plus 2x2, which becomes 2 plus 5x2 plus x5. Which means that since we're maximizing, we haven't finished yet because we can do better by having x2 or x5 enter the basis. And x2 looks more promising. So we have x2 enters. And then we go up here and we say, so as x2 goes up, then we look in here, look in this equation here, x3 will go down. And x2 therefore can only go up to 14/6. So when this reaches 14/6, then x3 starts to become negative, which is no good. If we look at this equation, then we have as x2 goes up, x4 comes down, and then the highest that x2 can go is 5/4. And finally, the last equation here, as x2 goes up, x1 goes up. That means there's no bound on x2 from this equation. And this is going to be the same logic that we're going to use later on to find that there's an unbounded solution, that all variables can go as, the entering variable can go as high as it wants, because this happens with all the equations. But here it only happens with one, but we just write down that x2 then goes to infinity, can go to infinity. It's the first 2 equations that are limiting x2, and therefore, since 5/4 is smaller, therefore x4 will be going out of the basis, so x4 departs. And then let's write down what the new basis is. So the new base, the old basis used to be x3, x4, x1, and now since x4 leaves, so x3 and then x2 enters, takes its place. And the variables not in the basis, just so we have complete, is it used to be that x2 and x5. Well, now it's x4 and x5. And now we're ready to move on. Using the new z equation, we have identified that the new entering variable is x2 and x4 departs, and we have a new basis. So now we can do the pivot. In order to do the pivot, we need the equations. So here are the equations from the previous slide, x3, x4, and x1, and the z. And we have the new basis. So x4 departs. x4 is no longer basic. So we're going to have this one right here, and we're going to have to work on that one. So we need to put x2 on the left-hand side. So we're going to have x2, is equal to 5/4. We're going to have to multiply by 1/4 minus 1/4 x4 minus 1/4 x5. And that we need to substitute in the various other equations. So we're going to have x3 equal to 14 minus 6. Then we substitute. And we do a little calculation. So x3 is going to be equal to 14 minus 30/4. 4 times 14 is 40 is 52. 52 minus 30 is 12. So we have 12/4. That's just 3. Yeah, this is 13/2. And it's going to give, let's not bother working out the other terms, because I think I know what's going to happen is that this solution is going to be optimal. If it's not, we'll have to continue working on this. And then the other one, which is x1, which will be 2 plus 3 times x2, which is 5/4 plus something, and then plus x5. And again, if we just want to know what the constant is, then we're talking about 15/4. 15/4, 8/4 plus 15/4 is 23/4. And there'll be other terms. Now let's look at the z, see what's happening there. It's 2 plus 5, and x2 is 5/4, and minus 1/4 x4, minus 1/4 x5, plus x5. And let's see how this works out. This is equal to 2 plus 25/4. So that's 8, and 25 is 33/4, minus 5/4 x4, and then minus 5/4 x4 plus x5 is minus 1/4, minus 1/4 x5. So lo and behold, we can stop. So we have solved this problem. We ended the phase 2 method. We started with an infeasible solution, had artificial variables, got rid of the artificial variables, found the basic feasible solution, and then moved on from there to improve and move along the feasible region. And we found that the optimum solution then is x2 equals 5/4 and x1 equals 23/4. For an objective of z equals 33/4. And that completes this operation.